Hey geothermal students, welcome. Looks like we're into topic 5, and we're going to talk about our median temperature lab today. I'll make sure that everybody's getting a little grip on that. Remember back here in topic 4, talked a little bit about it, and I think the initial assignment is back here in topic 3. Let's see, is it in there? Not seeing it. Okay, so I guess our first discussion was just in topic 4. Let's take a look at that real quick. Okay, so I know there's something more preliminary than this. Let me see if I can find that for you real quick. Maybe it's all the way back in 2, huh? We talked about instrumentation. Well, maybe it got deleted. Yeah, okay. Well, let's get with it today. The median earth temperature explanation from last week, from topic 4. Median earth temperature lab. Now is the time to start our experiment to determine median temperature in your selected site. So we talked about what you could use for temperature sensors. You know, you can buy this OMEL USB, which is a $65 or $70 item, but it'll automatically log or record for you. So you can set up with, I think, up to 100 recordings per day. So, and this might be something that you would carry into your professionality if you were going to go and search for geothermal resources. But just as easily, or just as well, easy to use is the indoor-outdoor thermometer that you can get, like a weather station at Costco, or just go to Ace Hardware and pick one up for $12 or something, that has a little remote sender, and then you can just take that and stick it in your site. But the thing is, we need to make sure that there's some kind of a continuity or shielding so that the site is not affected by sun and wind and airflow. So it's your decision. The only problem with the manual is that you've got to maybe choose 8 in the morning, 8 at night, 6 in the morning, 6 at night, or something like that, and then you need to write it down. So go out and record the temperature. What's nice too is you can get relative humidity on that Costco weather station that I have, and I think it was like $20 or something. So you don't have to spend $60 on it. Anyway, place your remote sensor, temperature sensor, at 72 inches below soil surface. So you don't need to dig a hole and bury it. You'd like to have it accessible. So you can take a piece of Schedule 40 white plastic, 2-inch, or galvanized pipe or whatever, and then you want to cap it so you don't build a core sample in the pipe itself. So cap the bottom end of the pipe, and you want to drive that pipe down in if you have the soil for that. Or you could just use an existing well casing. If you just went out in the backyard and you've got a well on your property, or if you've got a drain system of some sort where you can just take your tape measure and stick it down in there, and if you can get 6 feet below the surface, then hang it on a string down in there and just cap that off so that there's no air getting circulated through it there. So you could pound a pipe with a post pounder. You could dig a hole and place the pipe. I'll tell you, digging a 6-foot hole though is not as easy as it sounds. I mean, because you got to get your shoulders down in there, and pretty soon it's got to be 3 feet wide at the top, unless you got one big post hole digger, or a backhoe. Now you're talking, huh? 2 scoops and you got it. So do place it at 6 feet if possible. Now some of the guys in the past have actually just used a basement. Get down and around a basement, that's 6 feet below the ground, but you can't have a lot of airflow through there. So if you did get 6 feet underground up against a concrete wall, and you could see a place where you could shield off your remote sensor, maybe put a cardboard box over it, or lay some insulation over it or something to keep it so that air circulation doesn't spoil your results. But then, I mean, you don't want to put it right next to the heater or anything like that, you know. I want to look at, hey, look at my median temperature is 82 degrees, and I said, well, that's in that picture of his site. You could see the bottom of the furnace leg there, you know. So, no, that's not working. So, get yourself 72 inches, below the surface. Like I say, you could even use a drainage of some sort if, as long as you're not going to plug it up, because you can't let air flow through it. So, okay. Top of your sample well must be capped to prevent air circulation, which could taint your data. And data must be recorded consistently, so, twice a day, 12 hours apart, hopefully. But, if you're not up for 12 hours, I'm not. So, you could do 6 in the morning, 6 at night, something like that. Okay. Then the USB compatible device is pretty handy as far as being able to program it. 12 and 12. So this would be nice because your heat of the day, your what we call your burning period, probably would be about 2 in the afternoon, 2 or 3 in the afternoon around here, depending on what time of year. But this time of year, you're still 2 o'clock, 3 o'clock, you're still is your high temperature for the day. And then, your low temperature is likewise 2 or 3 in the morning. And my low temperature this morning was right when the sun came up at 7:30ish. That's due to an atmospheric compression that happens. It's kind of neat. Okay, but record your data temperature manually daily at convenient times, AM and PM. 14 days, please. So 28 entries. 14 days at 2 entries each would be 28 total.
We had some of those USB recording devices for practicum. They're still floating around here.
Here we go. So if we start looking at different data loggers, if you were going to try to get into, there's guys that go out and start their own businesses searching for geothermal resources, and basically what they do is go out and pound a 2-inch pipe in the ground, and then see what kind of median temperatures they have, which is what our lab's going to be all about. But like you say, $81.50, $150.
Right.
But they're programmable, so you can set up a whole bunch of them and then go away and come back in a week and see what kind of median temperature you have. The median temperature, there's some global stats on it. It fluctuates quite a bit, especially down in the tropics.
Oh, I bet.
Yeah.
Some of the stuff is wrong out here.
What's that? We were just checking out Joe's Island down here in Belize. And, well, cool, look at what I've done over here, Joe. You notice how the water's shimmering there?
Oh, yeah.
So there's on the side over here, if you get down into this, there's this new stuff. It's, what's it called? Voyager.
Oh, yeah.
And that has a bunch of different stuff. Sometimes it's too much, but like 3D cities, Earth view, landscapes, and then there's this thing that says oceans. There it is, right there.
Yeah, I got mine going too now.
Sweet. So it kind of helps you see the surface, and then you can actually look under the ocean. We'll do that in our course too, and look at the substratas and stuff.
Really?
Yeah, and right in here you can see there's if we look out in here, Joe, you can see the red line there, and then the green line here.
Mm-hmm.
So then we go back over here and start looking at the fault lines. So here's the earthquakes. You get on the USGS, then you get these additional features and tectonic plate boundaries, which we were talking about. You can see here, they're got this yellow line is a continental converging. Continental rift boundary is this, well, excuse me, that's white, I guess. It's kind of yellow. This is red. And if we see the different colored boundaries right here, if you click the boxes, you can kind of see, okay, I see this green boundary right here. And I'm thinking it's an oceanic transformal boundary, so I click the box and it disappears. So that tells you, okay, that's what it is. It's an oceanic transformal boundary. There it is. And transformal meaning that it's, you know, kind of rubbing side by side.
Mhm.
It's not,
And this-
yeah, it's not really subducting going under,
Right.
or it's not pulling apart. A rift, you know, pulls apart, and the transformals kind of go side by side, like the San Andreas is a transformal in a lot of. I mean, well, it's a combination because you see here the red is probably,
Spreading apart.
yeah, I think it's. Let's see what happens if we do this. No, it wasn't. Huh?
Convergent.
Yeah, let's see. Huh. Not a conversion either, huh? Let's see what else we got. Oceanic spreading. It's hard to see that color, I guess. I see the white one, which would be a continental converging plate. No, it's not, though. According to this, anyway. There we go. It's a continental rift boundary, just on the other side of that red. So when I
Okay.
clicked on continental rift boundary, it went away. Now here it comes back. So it's a small portion of that. If we kind of get up, bring it up. So I'm curious about this.
Just that little red section.
Yeah. I would think that'd be some type of convergence
Mm.
or separation, you know. But it doesn't seem to be going away when you click on the. There we go. So this one out here is an oceanic spreading. So similar to your rift.
Hmm.
Another one there. Maybe it's a combination or something that doesn't go away. But then you can see the Pacific Ring of Fire, huh, man?
Oh yeah.
So there you go. And your island's kind of like right in there, isn't it?
Yep. Well, it's closer to the.
This-
That's like right where you're at is in the middle of the Caribbean Ocean. Maybe quite a bit closer into Belize.
Okay, way over here.
Yeah.
So there's some shielding for you, huh? I mean, as far as I guess stuff can come ripping right in the right there. Whoa, boom, huh?
Well, the great thing about that being in a reef atoll is any storm surge breaks on the reef
Sweet.
wall, and so it's like lake water around the
Mhm.
island.
Then another feature that's going on here is this. If we go to that USGS site, okay, we got the Google Earth thing going. You'd also like to get this USGS download. If you just look for USGS, and then it'll bring you up to www.usgs.gov, and then give it a chance to download. It took a while for this stuff to happen, and then over here in real-time earthquakes, if you click on this, you can see where it comes up to a map section here. And then in that map section you have the opportunity to go to, well, this you can zoom out actually. Zoom it in there. See, it's a flat map, and you see all the tectonic interfaces here. That's what the red's all about. And then these earthquakes that you see right here are, you know, in the last day, last 24 hours, and red within the last hour. And I think I might see one right up here. Let's see who's in the last hour. And if you click on it, and see the guy on the side lights up, 2.5 on the Richter scale, 74 kilometers west of Big Lake, Alaska. Occurred at 9:29 today, 18:37:19 UTC. You can see there's two of them there. Take a look at this one right here. 59. Okay, this one was a little bit earlier. I'm not so sure that these, the way they're listed is like, you know, youngest to oldest. I think it kind of jumps around. And if you get in here, you can look and see, you know, which earthquakes are included on the map and list. And you can manipulate that also. I kind of like to take over here on the tools on the right hand side up here, get into the tools, and you can determine, okay, I want to get everything within 1 day, magnitude of 2.5 worldwide. Or you can go here to 7 days, 4.5, and then you'll see pretty much nothing. Hopefully. There might be something going on down in let's get rid of that. Go away. Let's go way on out of here. Oh, there's a little bit going on.
2.7 Puerto Rico.
2.7?
Yeah.
Puerto Rico, he says. Today?
All about the Caribbean.
Mhm.
It was.
Yeah.
Can't tell.
Well, there we go. Right here. Take a closer look at some of these guys.
29th. Yeah, what's today?
Okay, magnitude 5.0, French Harbor, Honduras. Look at that.
Ooh.
30 kilometers north of French Harbor.
Honduras?
Yeah, let's see what are the details on. Oh, there. Time. Oh, that was yesterday.
It's not showing up.
Cardenas.
Earthquakes to display.
I do want to get rid of this sidebar here. Let's do that. But if you get into the toolbar over here on the side, opens up this side panel, and I kind of like to, you can look for magnitude, do yourself information. I like to go newest first as far as where it goes, and then the satellite picture is pretty cool. Get the satellite overlayment. Get rid of this. This thing really zooms, man. But now we're into a Google Earth deal. So let's see what we were looking at earlier. And here's, so now I'm kind of locating your island because of that fault that goes through there. And there it is right there. You see the stair step in it? Joe, right here?
Yeah.
This is pretty common in transformal convergent faults. Like the San Andreas, if you look at that, it comes right up. So you look at the stair steps in this coming up through the Gulf of California.
So what causes that?
Well, it's, if there's movement, and then as it relieves, it's kind of it's a result of physics, As you stress, it tends to fracture, and then it'll subduct or rift out or separate,
Right.
as it moves. But instead of breaking in a nice clean line, it's kind of like glass,
Mm.
But you can see how that has that same kind of something I didn't notice until I really got into Google Earth is how these faults work, like this. And this all tends to be if we go back to Google Earth and try to look at that fault, you can see here where it's a oceanic transformal. Transforming meaning it runs side by side, kind of maybe running in two different directions, or maybe one standing still and it's just moving past it, but more scraping side by side than subducting or going under. But you can see then there's some subduction going on too. Well, this is the oceanic spreading, I bet. Yep. And then when you take that away, you can still see this feature, which is pretty cool, which is probably something to do with the bottom of the ocean there. So there's actually something going on with the crust itself. And then a little later today, we're going to look at the mud pots up here in Salton Sea. And I got a surprise for you. What does Tesla have to do with geothermal energy? The question for today. What could Tesla possibly have to do with geothermal energy? Now, I've got a few too many layers going right up in here. You can see that it's obscuring what I want to see. Pictures, different features over here. So I'm going to go get rid of some stuff. Actually, it's up in here. Voyager. So it gets kind of cleans it up a little bit, and then I want to keep Oceans though. And then they have diving spots too, Joe. I think it's Ocean Sports right here. So if you click on Ocean Sports, then see these diving as will show up. See the diver flag?
Yeah. Your paddy flags.
Yeah. Main Top Island. Photo 0. Alright. That was the dive master for Mount San Antonio College out of we dove out of San Pedro over to Catalina Island. And if you look at these islands, it's kind of neat the way they relate to the coast of California in general, or to the North American continental plate. Get a little further down here. I'm surprised they don't show some dive sites, but down in here we go. This must be Catalina right here, I think. Here we go. Net Reef, Peacock Wreck, and then there's Ship Rock. I think that might be Ship Rock right there. No, it's not. But it's a spire. It goes about 100 feet down to the sandy bottom, and the blue sharks like it. Have you seen blue sharks?
Oh yeah.
Yeah, they're blue.
Mhm.
All you see is eyes, teeth and eyes now and then, you know. And then when you do the shark dive, you take your tank off and hook elbows with your partner, and so you're back to back. And then when you're down there, and the sharks are like, "What's up with those bubbles?" You know. I mean, who knows how many thousands of divers they've seen anyway. So it's not like they're going to attack you, but they still might want to just see if you're edible. So when they come in to take a chomp or just kind of brush you to see what's going on, you nudge them with the tank, and then they take off.
Mhm.
But just like they're circling, and they get closer, and pretty soon they come in and try to rub you. So you just get the stem, but like 72 cubic foot usually is what I dive with, single.
Mhm.
Boom, give it to them, But the BC is not incorporated in the backpack, and a lot of the newer ones are, aren't they? The tank, it's all one piece. The buoyancy compensator and everything is all
No,
incorporated.
they still clip in. And,
Oh, sweet.
Yeah.
So you can get it off and do that, Otherwise, you're like, oh, what the
Yeah, it'd be easier just to take the whole thing off, and hold on to the BCD and everything. You could still keep your reg in your
But
mouth.
it's 60 feet here. It's getting kind of dark. The clarity's not that good usually. But I used to always want to go out here to San Clemente, Prince Island. Where's San Clemente Island at? Bull City. Captain Hook. I thought that was San Clemente right in here. It's not telling me. But you got Catalina, 26 miles across the sea. Santa Catalina is waiting for me. Remember that song? Probably not. But come across there, and then I saw why you might not want to go diving at San Clemente. Turns out that San Clemente Island is a breeding ground for great white sharks.
Hmm.
Looks like he's got a seal right there.
Yeah. That's some pretty impressive footage. You got those guys coming out of the water.
They do. Let's get this rolling for you.
Seeing an attack from underwater is really amazing. It's something we never get to see.
Missed it. Let's try it again.
it came up.
Come on. There we go. Freak it out. Come on, baby. Oh, stinker on me. All those little signs. Right back into it.
Jeez, it came up so fast, I hardly even got a chance to see it. You could see that it came at a tremendous speed. Last minute, opened its mouth, and then the inertia just took its air of the water, as you'd expect.
Oh, he's on. That's a
Going at
decoy.
high speed
You
like
see
that,
the
it's
line
got
on
very
it?
little time
Yeah.
to actually make a cognitive decision. Does it go for the
Sweet.
camera? Does it go for the shape? What does it go for? And in virtually every instance, it goes for the right thing. Come look here, quickly!
But you see, these guys are
And the fact that
obviously
it completely
Australian.
missed the camera also teaches us something. You know, that these animals are clearly able to distinguish what is normal prey from what isn't.
Thank God. You know what I mean? That guy, I wish he's 20 feet plus. He's a big boy. Well, you know what I heard? I heard that they don't like live stuff living in the mountain. And the footage they took off the California coast, they showed them not even biting. They would just swim up and knock them out,
Right.
and then come back after they were later when they were dead and eat them up because they didn't like them wiggling in their mouth. That's what I guess that's what they were trying to say. I don't know if it's true or not.